Welcome to Happy Friday and Bifrost Day. Should we name it as Bifrost Day? Cool. I did also go through and first of all, I sent you guys your homework sheet for chapter 7 about an hour ago. So you guys got that or gonna get that. Second part, we're in 7.2 today. And then I outlined the rest of didn't realize there was just so many days left. That's it. So I went ahead and made an executive order. We're going to skip 7.6. So chapter 7 is only going up to 5. And there is a question whether there's going to be TRIG class here because, anyways, I need to find out for sure.
Oh, that day, I think that
I'm not sure it's still a half day or they made it into a full day or not.
Yeah,
so
on the English syllabus, it says only electives, but that doesn't mean anything.
Yeah, Mr. McCullough's syllabus doesn't mean anything until like 2 days before.
Got it.
So then it's probably right.
So I'm thinking 7.5 then, if we do have class. If not, then I'm going to send out a video for 7.5 after that. Cool. And then in June, guys, real quick here, this is the June schedule. Let's talk about it just in case we need to change things. So Wednesday we come back after Memorial Day, just chapter 7 review. And I send you guys a chapter 7 take-home exam. We're good? 8.1, 8.2, exam due 8.3, 8.4.
Oh my gosh.
And so my question to you guys is this right here, is presentations here or final here? What would you rather like?
Final. Yeah, I go final first.
Final first?
We have a bunch of finals that week. Yeah, like
That's what I figured
yeah, I
too.
don't want that the same week as.
Yeah. So all this stuff here, changed up. I would rather do that and ask you guys here. Look at that. Oh, final disappeared. That's awesome.
Wait, so there's 2 verbal finals?
Just 2 days for verbal finals just to get through everybody. Okay, so we're looking at something like this. Something like that. Is that good?
Yeah.
And then this guy too. Presentations. I'm thinking that. Oh, this guy gets going to be replaced. Stick it onto a Thursday. How about that?
How can we do it on Thursday? He's just. Yeah, no,
Okay, something like that. Will that work?
What are the presentations on this one?
Same concept. Whatever you enjoyed in the class, whatever you want to dig deep into the class or connect to real life. It's going to be a little bit more scrutinized than last one. And then we didn't see each other, so I really want to make that happen for you guys to sort of see each other. Presentations here. So start thinking. Okay, does that work about right there?
What does the verbal final look like?
Ah, did we have in this class? No, we skipped that one, huh?
Yeah.
That's right.
You told us about it.
Yep. Anywhere from 6 to 10 problems that are from the textbook itself that you have done already for homework, and you present it in the class. These usually are encompassing, so by the time you do this problem, you should have a good handle on like solving equations. That would be like, wow, you know this here. So you do have to, in a sense, memorize it to the fact. I will have ballots sitting right over here. You come up, you pick one, and then you go to the board and you explain. And points are getting it correct, obviously, that I don't have to correct you in the process. You explaining your work, and you put down kind of like formulas or whatever you need. You're like, okay, we need this formula for this, and you plug it in. So it's explaining the problem itself.
And that's for chapter 8.
That's going to be the whole entire textbook.
So are you gonna give us problems to study?
Yes, I'll give you 10-ish problems that cover the textbook. One from each chapter for sure. I may need like the second one from the chapter just to sort of get a full emphasis of the chapter. Cool. No, not cool. Love it. It's torture. That's me. The concept here is in classical education in other countries, particularly in Europe, they have what is called ballot systems. That's exactly how they do it. In fact, the whole week, you don't go to class the whole week. The whole week is you go to one class each time to take your verbal final. And it's roughly anywhere from 20 to 60 questions per subject. And then you're studying those. You come in, do it. The premise behind it is if you can teach someone else, then you know the subject. That's kind of.
Yeah.
Do they do that for other subjects too? So like English? And
Yes,
history and stuff?
every single class, whole week. I should give you guys the, there's an old black and white Russian movie where they're studying nonstop in order to prepare for the finals, and then the cheating that happens afterwards, which is actually humorous. Let me see if I can dig that up. That's fine. Okay, are we good with this one then? 23rd, I think, is a half day for sure, right? So then any remaining verbal final didn't get through on the 16th, they're gonna go here.
Wait,
Okay.
so how are they gonna do the half day?
I have no idea.
Because like we all get out of class by like 10:45 on those days. So it's like, are we just gonna?
Well,
Don't know.
For that one day, it's just electives.
That's not.
For the
Oh, that's
23rd?
Friday.
Oh,
That's
I didn't know
Friday.
Wednesday was a half day.
Like cut each
How
I
many?
feel like Wednesday's always a half day.
Oh my God.
I thought we just didn't have class.
You don't know.
Wednesday.
I don't
This
know
is the
if this is
worst
true, but Mr.
possible
McCullough
thing
on
to
the
do.
study guide put
It's
party.
not that
What
complicated.
does that mean, like
No,
party on
people
the
are making
No,
it
that's
complicated.
where normally we like
It's
get
class,
here.
you seem like the worst
I feel like
person.
at like 8 or
lunch.
9, and
Oh
then
my God,
we,
it's not that deep.
remember we like watched some movies,
Oh,
and then we,
Yeah, freshman year was definitely not a half day. One of the last class after school, it was like after school.
Yeah.
no, it was a half day, because we like I remember like going and getting lunch like right after.
see, I'll be completely honest, I don't remember freshman year
That was
and the
the
year
only
at
half day of
all.
school we had.
No, I got like
In
wet
my house.
Skittles on your shirt.
We only had one last day of school.
And popsicles.
And that was freshman.
Yeah.
Oh, that's true.
I
I
know.
remember any last day of school, that
There was no other one.
All right, look,
No,
Jan,
Also,
I
what are
think
we
you
doing
spilled
with the
something
text?
on a plate with Skittles on it.
you guys are just submitting it to me before end of class.
Threw the Skittles at
Like
you.
giving it to you?
Uh-huh.
Okay.
All right, so you should be able to give me your exam today, right, before you leave? That's what I want as
And
well.
that's how we became.
I will grade it during the weekend, give it back to you for corrections on Monday. Okay, we good there? So just have it out. Don't forget to give it to me before you leave. Now let's jam. Let's see if we can finish up 7.2. 7.2, let's go back really quick here about different cases. So again, the ambiguous case, it's the stuff that given the three numbers, you just don't know if you get a triangle or not. Have to do it, it's theoretical in some sense, and then we'll do a application problem where it's actually found here. So let's jam here. This one is the no solution case. You know that, and this kind of predicated upon the fact that it's a less than 90-degree angle here. So the angle that you want here, less than 90 degrees. And then the comparison is between the other side over here and this side over here. Even more so, what's the sine of that angle, right? Because you just need to get to the other side. And 2 is just not enough to get to the other side. If you take the adjacent side times the sine of your angle, that's kind of what you're looking at. And you're comparing it towards the opposite side of the angle. Cool. No solution, we good? Jamming. The solution 2, you need 3 as minimally, and you get 3 for A, so therefore you got yourself barely, but you got yourself a right triangle. So you made it to the other side. And then you go to 4 for A, and then you got yourself more than you need. So therefore this triangle could actually swing towards the back end, look like this, or towards the angle itself and look something like this. We good? Boom. And then the what's the solution case? What happens if the A value is actually bigger than the B value? If that's 8, it's actually higher. It doesn't swing this way anymore because you don't have the 30-degree angle anymore. So the only one is this way right here. And it's going to be a long angle over here. Cool, we're good there. Next is the other case. More than 90 degrees. Only thing we need is we need this guy to at least get back to the other side. So we need at least this guy to be greater than greater than 6 or greater than B, and it isn't, so therefore you can't make it back. And not possible. This one, where the A now is bigger than the B. So notice you just check your angle for whether it's over 90 degrees, and if it is, it's just a comparison between A and B at that point. Okay, are we good?
So wait, in any case where A is bigger than B, because it seems like A could be slightly bigger than B, but still not reach that last one.
Say that again, say it again.
Is it in any case where A is bigger than B? Because it seems like A could be just slightly bigger than B, but still not reach the bottom line.
Yeah, if this A is like 6.1, if it's just 6.1, it's gonna end right here, but you still have your angle of 130 degrees.
Oh, right.
You still have the 6, and you just have enough. If it's exactly, I should say if it's exactly 6, still not a triangle. It has to be bigger because it has to form that triangle. Okay, so Jam, I think, did we start this one or no?
We already went
Oh,
through.
that's cool, yeah, for the 2 solutions ones, right? Okay, so let's jam with the time remaining. This one, we are at 5 then?
Yeah.
And we're just trying to get angle B. We can solve for angle B. We at least do the law of sines to get the rest. And so let's jam time remaining here. So this is what I tend to circle here. I tend to circle the angle, and I see its opposite side over here. And that kind of informs me, whoa, I think I need to check whether I have a triangle or not.
So do we have to memorize the cases, or are they in the book?
They are in the book, and we'll get there in just a bit. Okay, 20-degree angle. I'm going to go like this, like this. That's 20 degrees. And at this point, I noticed that this guy's 12 and this guy's 14. Nice, dead giveaway. This is case, what do you guys say? Case 4. Sweet, one angle, it just goes all the way over here, right? And that's what I have right there. So now the question is, can you give me this angle here? I should label it as A, B, and C. On the homework, eventually solving for a lot of them, for everything. But in this case, just practicing solving for B. So it's just a law of sines, true? So how about sine of 20 degrees over 14 is equal to sine of B over 12. Cool, multiply through, that's 12, sine of 20 degrees over 14. And then on the calculator, we're just gonna take sine inverse of that to give us B, and all yours. Make sure you are in degree mode. Kind of helps to be in the right mode. Let's see, and nearest degree would be fine. I think that's the way it's in the book.
That's 17.0.
Okay, I'm gonna go 17. Anybody second that? Boom, okay. Anybody third that? Okay, cool, 17 it is. Nice, okay. And notice from here though, we can do the law of sines from here on out. Right? So then go from there. Okay, one little tiny thing that we have to think about, ready guys, is we'll start over here. If you can, there's one particular question in the textbook here. When doing the law of sines, you want to go for the smaller angle first. So smaller angle is what you want to solve for. The reason for it is, remember when you do the sines across the unit circle, in quadrant 1 and quadrant 2, you guys talk to me here, is sine the same in quadrant 1 and quadrant 2 as far as
Wait, what does that say?
Smaller angle. You always go for the smaller angle when you go for the law of sines. If you notice the y value here, it's 0, right? Then it goes up to 1/2. Then it goes up to √2/2, then √3/2, and then it gets to 1. Right? And this is angles from 1 to 90, right? But then when you go the other way, this is going to be exactly the same. It's √3/2, √2/2, 1/2, back to 0. So notice whenever you're taking this little piece right here, sine inverse, I think we talked about this here. Remember, sine inverse only works in quadrants 1 and 4. If it's negative, works down here. If it's positive, works down up here. So kind of a little bit of a trick in which you have to, we're working here, right? We have no negative angles. But the law of sines is only going to give you a value between 0 and 90 degrees. It's not going to give you 132 degrees. Good? So just be mindful of that when you're doing your homework. So if you're going to do this here, yes, you would solve for this. And then you would add these together, subtract from 180 to get this guy.
So what does it mean to use the smaller angle?
We'll get there.
Okay.
Just to put
Wait,
it through your
so
mind.
what the problem like is saying for us to do is solve B and then solve for C?
In this case, you have to. You have to because that's the only thing you know. You don't know its opposite side. So you are set in order to solve for the other side. If it's possible, what you want to do is you want to go for the smaller angle, and we'll see that in a bit.
Wait.
Let's see.
Wait, I'm so confused.
Yeah, sorry guys, confusing you guys. Let's put this aside for now. Just forget exactly what I just told you
Okay.
for the last 2 minutes.
So like when you say you're trying to solve angle C, like are we supposed to solve angle C to complete like what the problem is asking us to do?
Yes, eventually. Let's go. Let's see how this works out. Ask me questions toward the end if you need to. Okay, the next one on the list. Let's see. All right, 120 degrees. I'm thinking this right here. A value, so B value is 12. And then the A value comes down to be 10. Are we good? The answer is no triangle. Case number 5, I believe, right? Second to last case. Okay. That is so interesting. Now that I'm thinking about it here, on these cases, you always are going to solve for the for an angle less than 90 degrees, and then you're going to move things over here. So all yours this one. Degrees. So this guy has to be past 90. B value is 12. C value is 15. Do I have myself a triangle? Sure do. That's enough to reach to the other side. Case number 6. That's cool. And let's go with it. Let's solve. Sine of 135 over 15 is equal to sine of B over 12. In this case, I should label my triangle now. So A, B, and C. 12 here, same exact process here. Looks like more like a 5 or a 15. Sine inverse, and we got ourselves a possible answer here. Okay, second, third, awesome. Okay, 34 it is. Okay, are we good there? Are we comfortable with those now? Because this is somewhat abstract here. Okay, in your textbook, we do have, good there?
Wait, did you get 34.4?
Yeah. Got a couple of people still finishing up writing here. Cool. All right, in your textbook on page 352, that's where we find these guys here. So if you want to refer back to them, if you need to, maybe just write down page 352. It has 1, 2, 3, 4, 5, 6. It has all 6 of them in there. It starts off in a different order than we did them. Starts off with the no solution pieces, and then it goes on to the other ones here. So how about this? For each one, give me the cases here. So this one right here, which one is this one? Going back to our notes here. Case 1. Okay. That's okay. Good, good. Just a little bit, and then we move on to the one solution. Four. Ooh. Say it again.
For the bottom one, it says A is greater than or equal to.
Oh, yes, yes. If A and B are exactly the same, let's go back in our notes here. Let's see. Let's go.
A and B are actually the same.
A is greater than or equal to B.
It's just being nice, honestly, sure.
Mm-hmm.
Yeah, that one's case 4.
4, yeah. Let me go back in our notes here. And then I messed it up a little bit here. This one should have been equal to. This is, it should be that one then.
And this is number 1, right? Or no?
This is 4.
What case is this?
Okay.
This is case 4. Thank you so much. That needs to be corrected for case 4. Okay, there. Good for case 4. Yeah, it is a less than or greater than or equal to. Okay, jam in here. Now this is case number 4. Okay. Case 6.
That one's case 3.
Awesome. Boom. Okay. I'm just thinking in our minds, mathematics is interesting because you deal with numbers, right? But you deal with them in a similar abstract level, right? So there's any time that you deal with things and like, oh, these are different categories of thought, right? And into something, this goes into this thought, this goes in this thought. I need to think about this way, and this I need to think about this way. Anybody give an example that has that in your outside of mathematics? I'll take that. Let me think about it for a little bit. Okay, but let's go with this one. Okay, example 5, here's what we got to do. We got to find every single piece of this triangle. So I have C is 51 degrees, 30 minutes. Oh boy, now we got to deal with the minute stuff. C is 707 meters, B is 821 meters. and let's go with it. So it looks like we're going to go to the nearest minute on these guys. And notice, oh man, notice our, there's no A in here. That's no fun. So the most easiest way to do it is, the question is this: do you have a angle and do you have its opposite side? Yeah, I just circled them. So in this case, it's the ambiguous case. Now I've got to figure things out. If it wasn't that way, if we knew another angle, then that would have been law of sines easily. So in this case, it's C over here. So I like to draw my triangle. So this guy has to be C over here. So I'm going to draw a little bit differently. And so since I know B would be over here. So that's what I always test. So that means angle B would have to be over here. That means angle A is up there. Are we good? At least the rewriting of the angles. Okay, so now, let's see, this is 707. So it is going to come down this way, right? I'm not sure if it gets to the other side or not.
Wait, why would it come down?
I'm not sure if it comes down straight down. I'm just testing to see if it's at least gets to the other side. And then we got to figure which case we're in. I'm thinking like, let's see, my, one of my many brothers, is a mechanic. So when he looks at a car, right, it's making a certain noise. Okay, if it's making a certain noise, then the question is it doing this, right? Or is it doing this? And based upon, usually he says in a car, usually it's 2 or 3 things. But once you understand those 3 things, you know exactly what's wrong with the car. So tires are making a grinding noise. Okay, if that's the case, let me do this. Is the engine revving when you make the turn? No, it's not. So therefore this, therefore it's the end, right? And then you know exactly what it is. I think it's something like that. My brother-in-law, he owns a heating and air conditioning company in Idaho. And so for him, when he goes to inspect, it is exactly the same way. It's almost a schematic actually. Is power turning on? Yes or no? Is it getting warm? Yes or no? Is the evaporator coolant turning on? Yes or no? So based upon that, you have these categories of thought that says, okay, that's the issue. But I think that sort of lends itself to this. It's, hey, we have this and this. It's case, okay, it could be case 1, 2, or 3, or 4. Nope, it's going to be either case 5 or 6. We're good. So those sort of categories of thought. We're practicing it with numbers, but we do it quite a bit in life itself. Like, is Grant having a good day or not? Okay, then we, stuff like that. Anyways, go for it. Case 1, 2, 3, or 4 for this one. Do we know? Let's see, it's not, 707 is smaller than 821, so I know that much. So it's not case 4, right? So then I'm thinking it's either case 1, 2, or 3. To test for case 1, 2, and 3, we have a little formula. Now this formula has to be changed a little bit here, right? So H is equal to, it's going to be B, right? But in this case, we're going to change it to sine of C. Are we good? As opposed to sine of A, because it's the C angle that we know. And this is where we get to a little more abstract than just the formula themselves, right? We always use A all the time, but understand you can switch them out really easily. Okay, B is 821 times sine of 51 degrees, 30 minutes. Do you guys still know how to put that into your calculator?
No.
Say again?
You have to make it into decimals and degrees.
Sure, yep. So how about, let's see, 30. Oh, this is easy. Hold on, let's sneeze. Okay, now 30 out of 60, right? Because there's 60 degrees, so 0.5 is good.
Why do we use minutes? Seems like it just prevents us from using a calculator. Like, where's the application for that?
More specific.
But like, decimals are pretty
Is it?
specific.
Decimals are specific.
As specific as you want them to be.
You can go pretty far with decimals. You don't have to make it into like minutes and seconds.
Yeah, it's just like a different number system that your calculator doesn't know.
Well, then let's see. Why do we use fractions and decimals? Because fractions and decimals are the exact same thing, right? We have certain applications, I guess, specified. So twisty. Thank you. I'm thinking the only time I see it happen is when you're in military and you do need to put in like, okay, degrees, minutes, seconds. And it's a lot easier. In fact, military even has mils, milliseconds, technically. So for specification, you just put in those numbers or coordinates and you click enter and you're done, as opposed to, oh shoot, it's 516387345 decimal approximation. That's the only time I've seen it. Okay, all yours. What you guys get? 642.
Oh no.
It's 25, so if we want around here, it's 23.
Is it okay? Okay, what do we got here? What case? Go with case 3, right? It is enough to get past it. It's not the same as it. Thank you so much. It goes past it, but it's not bigger than 820. So therefore, oh, bummer. Okay, we have the 2. We have the 2 angle or 2 triangle case. No fun. Okay, so this is what I was talking about as far as getting the smaller angle first. So if this is the case, I know I have a triangle this way. I know I have a triangle this way, even though I scooted this a little bit too far. This guy's gonna be a big triangle. In fact, it's over 90 degrees. Your calculator won't calculate that because sine only works from 0 to 90. So what you want to do in this case, you just want to get this one because you know that one's gonna be less than 90 degrees. So let's calculate this first. So let's draw it out. It's going to look like this. There's my C value, my B value, my A. I know this is 821, 707, and this is 51 degrees, 30 minutes. Okay, and then let's do this here. Let's draw out the other triangle just so we can have the angle in front of us here. So the other triangle is going to be like this. It's going to be C, BA, 51 degrees, 30 minutes. Okay, now let's go for it. 5 minutes left. Let's jam. So sine of 51.5 over 707. Is equal to sine of B over 821. Hopefully by, let's see, at this point, can you punch it into your calculator right away? Without having to put down what you're going to punch in. All right, give me the angle measurement and let's see how we can work this out. Give me the degree measurement first.
65.3.
So 65.3, blah, blah, blah.
339.
Okay, 339, blah, blah, blah. So let's do this here. Let's subtract 60, sorry, Grant, 65, right?
Mm-hmm.
Okay, subtract 65 from it, and you're going to get the remaining piece here. Multiply that times 60. And what do you get? 399.
0.
Okay. Are we good with 65 degrees and 20 minutes? Are we good there?
What did we just do?
We took the 821 over here on the side, right? We took the sine inverse to get us B, And according to Grant, we got an angle of 65.3 something or other. So we have the degree value here. So let's subtract 65 from your answer, and you should be left with a decimal.
Wait, so why do we have to turn it into minutes?
Because the problem itself is given in minutes. Usually what happens is if you're given, it's kind of like scientific notation or scientific significant figures, right? If you're given a certain amount, you're going to give the answer in a certain amount. So in this case, you're given it in terms of degrees and minutes. To the nearest minute, you're going to give your answers in degrees to nearest minutes. Okay, good there. Next is, how do we find this little b right here? The 180 minus the 6520. Okay, what is 180 degrees minus 6520? I remember doing this. It's like in chapter 2, wasn't it, or something like that? We borrow 1 degree from here, make it a 179. That gives us 60 minutes over here. How about a good old 40 there? And I need 179 minus 65.
114.
114. Okay, are we good there? There's my other. Oh, hold on. We got another little problem. Notice I have 2 triangles. Yeah, go ahead.
Doesn't a triangle, isn't it 180?
It's gonna be 180.
But
But-
then, why don't we combine 65 and 51? And then
Sure.
subtract that from.
Wait.
Oh yeah, we are going to do that for angle A. Yes, eventually. We're just trying to get the other angle B.
Oh,
And the other angle B works like this, because this is a certain angle. If I put this line down, it's going to give me the same angle here.
mhm.
So that means this is just a supplementary angle to the angle I
I
have.
see.
No problem. Please ask the questions. That's what we're here for. Okay, 2.5 minutes left. Let's jam. A little problem. I have 2 angles that are labeled the same, and that's my problem. I can't have 2 angles that are labeled the same. So I know. So we're gonna label this guy as we call it C prime, B prime, and A prime, just to distinguish between the other one.
These questions are gonna be in the homework.
They are. Some of it's gonna be no solution, and you're gonna say like, yes, I love it. And then this one's gonna be like, oh, forgot 2 solutions. Okay, a minute and a half left here. Let's jam. So I got these 2 here. Let's start solving for each of them. So you guys tell me real quickly here. We'll solve them real quick. But give me angle A. So that one's going to be now 180 minus this, or add them together first and subtract from 180. What do we get here? I hate to go to the next slide here because I have to write everything over again. So for angle A, add them up, add the 2 angles up, subtract from 180. What do we get?
16 degrees and 50 minutes.
Oh, but I didn't subtract.
Okay, what'd you get for the addition here though? 1 what?
116 and 50.
15, sorry, degree right there. Okay. Very good. 116, 50 minutes, subtracted from 180. If you guys can.
About 63?
63, and I'm gonna go 6310 then, right?
Yes.
6310, guys, right there. And now we're gonna use the law of sines. We're good? We're gonna use the law of sines to figure out the little a value over here, and I'll give it to you guys. Try it yourself, but you guys should get 805. Don't try it yourself now. Try it yourself later as we do this one. So now the prime angle that we have. Can you guys give me this one here? It's going to be 114.40 plus 51.30. Subtract that to get angle A. Angle A is going to be very small. And notice when you add this together here, 51.30 and 114.40, you are going to get what, 164 570, is that right? That's no fun, because minutes should be between 0 and 60, so we're gonna add an extra degree here, so 166.10 is what I'm subtracting from 180. Are we good? Kind of going a little fast here, I know we're over time. Can someone find me A prime?
13 degrees, 15 minutes.
Okay, 13 degrees and 50 minutes, I agree. Okay, are we good there? I know it's a little bit hurried here. Can you guys use the law of sines to figure out little a over here? Or little a prime? I think you should be able to. We good? Okay, I'm gonna stop there. We didn't get to the vector problem, so just one problem left. We'll do that on Monday as we go on to
Can
7.
we do another one of these so we can kind of rush through it?
Yeah, let me do this here. Let me, in fact, let me do this here. I'm gonna send a video of another one like that with all the details on it. I will send you guys the vector problem as well. And then as a video here.
So what homework is due on Monday, 7.1?
7.1 and 7.2 up to the vector problems, if you could just at least start it. 7.1 would be due, 7.2 is just to start on. All right, and I need your exams. Come on down.